Today we're going to be looking at some different angles that we have in triangles and some of the different triangles properties. So the very first thing we need is the sum. So the sum of the three angles of any triangle, their measures will always total 180 degrees. Super huge, super important, need to make sure we know that. An isosceles triangle. So an isosceles triangle is a triangle with at least two sides of equal length. So the picture on the right that's showing us an isosceles triangle, these two lines on the picture are showing us that those two sides are equal in length. And then another property we get is that the base angles are also equal in measure. So these two angles here, these are called your base angles. That's because this part of the triangle is called the base. That's the one side that I would say is not congruent to the other two. The two sides that are congruent, those are called legs. So that's a leg, that is a leg. And then the angle that's situated between the two congruent legs, that's called your vertex angle. So those are the different parts of an isosceles triangle. Okay. Next thing we're going to take a look at is something referred to as the exterior angle of a triangle. So the exterior angle, and we're going to look at this picture below. It says let angle BAC, so that's this one down here, be an interior angle of triangle ABC. And let D, it's going to be a point on this segment. Okay. And it says so that C is between A and D. So if we look at angle BCD, so angle BCD is this one right here. It says that's an exterior angle of the triangle. So the exterior angle, we are thinking outside. And if you look at the picture, you notice it says that exterior angle is equal to A plus B. That's a really big property we want to remember. So up here it's saying in any triangle, the measure of the exterior angle is equal to the sum of the measures of the two remote interior angles. So these two angles, angles A and B, these are called your remote interior angles. And I think of them as being the two interior angles that do not touch this exterior angle. So I can see angle C is touching the exterior angle. I don't want to look at that one. I look at the two remote interiors. So the two remote interiors are going to be equal to that exterior angle. And then the last triangle we're going to take a look at is an equilateral triangle. And that's just a triangle where all three sides are equal in length. So again, if I look at the picture, I can see now I have three lines telling me that they're all three are equal. And if all three sides are equal, well then all three angles are equal. And like we learned up above, there's 180 degrees in a triangle. So if I split that up into three equal parts, we're going to find that each angle is now going to measure 60 degrees. So we're going to use all of those properties along with things that we have learned in the last unit with parallel lines, vertical angles, and we're going to try and solve for missing parts of triangles and their angle measures. So the very first thing, we're trying to solve for angle A, and if I look at this picture, I want to make sure I'm seeing that there's just more than one triangle. I'm actually seeing maybe even three triangles here. This triangle maybe being the first triangle I'm looking at. And within that triangle, I have two angles listed. I don't have the third. But because I know all triangles add up to be 180, I could say something like 69 plus 58 plus A would add up and equal 180 degrees. So if I wanted to solve for A, if I subtract out the 69 and subtract out the 58 from 180, okay, that's going to leave me with my measure of angle A. So I'd have to subtract both of those over. All right, so angle A, when we do that, is now 53 degrees. But I also see another triangle, and if I look, I have to find angle B. Well, angle B, if I were to even highlight that angle, looks like it's this angle right here. And if I extend this over, Well, now I see there's another triangle. And I'm looking at this angle 93, and that to me looks like it's an exterior angle. So sometimes these pictures get a little crazy. We got a lot of information going on. Might not be a bad idea to kind of redraw it on the side, label what we know, trying to find angle B. And if I'm looking in this corner over here, well, we know that that's 53 degrees. And from up above, we said the exterior angle was equal to the sum of the two remote interior angles. So if I want to find that angle B, if I subtract over 53, we're going to find angle B is now equal to 40. Okay, so we have another picture here. We have triangles, but we also have some other important things. We have these two little flags, I like to call them. That's just representing that these lines are parallel. So now we're going to have to go and remember some parallel line properties from our last section. So if I highlight those, we have two parallel lines. We typically looked at them with a transversal, a line that intersects those two. And I start to see some properties here. I see this angle of 78 should equal a whole bunch of other angles. So I see one location would be this location right here. That's a corresponding angle. So I know that that angle should equal 78. Now looking at that angle, I can see that that is an exterior angle to this triangle. So if I were to extend this line out, and again, think about, well, what do I know about an exterior angle? That exterior angle should equal the two remote interiors. So I have the exterior angle should equal my two remote interiors being 48 and F. So if I wanted to find out what F is, I would subtract it out, and I would find that F is now 30 degrees. So that's kind of combining an old topic and a new topic. Okay. Looking at that exterior angle property again, now notice everything's here. Okay, so I have my triangle, I have my two remote interior angles, I have my exterior angle over here. Everything's represented in variables, so I'm going to have to do a little bit of algebra. But then they want us to find angle J, which is the one interior angle that actually touches the exterior. So we have to do a little bit of work once we find X. So using our exterior angle property, I know I can add the two remote interiors and set it equal to the exterior angle. Okay, so if we combine like terms, on the left-hand side here, I have 9x, and I have a -5 for the constants. Nothing's really changed on the right-hand side. So I want to combine my x's. I'm going to pull my 9x to the right-hand side. Okay, be careful with your signs. And I want to add over the 20. And when we do, positive 20, -5, we're going to find x here is 15. But we're not done because they wanted us to find angle J. So in order to find angle J, I'm going to go in and find my exterior angle. So the exterior angle, I'd have to do 10 times 15, so that's 150, minus 20. So that's going to say this angle, my exterior angle, is 130 degrees. But I want angle J. So angle J and the one that we found for 130, these are linear pairs. They're two angles next to each other on a line. So that means if they're linear pairs, they're on a line, I should be able to add them up and set it equal to 180. So solving for J, subtract over the 130, and I would find then J is equal to 50. So that's just taking it one step further. Okay. Number 4, what you're going to notice is there is no picture. So now we just kind of have to be careful with the words that they've given us. They're telling us I have a triangle CAT, and it tells me side CT is extended. So I'm going to draw a triangle, and it tells me I have side CT extended. So let's label this CT, and it says it's extended through T over to S. I'll label this other angle A. So now here's my triangle CAT. We took side CT, extended it over to S. And now they've given us our values. So angle CAT is equal to x plus 40. Angle ACT is 4x minus 5. Again, notice those are the two remote interior angles. And then angle ATS, so that's our exterior angle, is 6x plus 20. So if we use that idea, the sum of the two remote interior angles is equal to our exterior angle, that will get us our equation. Okay, so combining our terms, I would have 5x plus 35 is equal to 6x plus 20. So solving for x, if I move the 5x over, I'm going to have 35 equals x plus 20, and solving for x, subtracting over the 20, I'm going to find x is 15. And in this problem, all we had to do is find x. And our last problem. So combining again a couple of things, have to find angle C. I'm noticing these two lines, probably one of the first things I notice. And what that's telling me is if I were to look at this triangle that I'm tracing out in red, it's telling me that triangle is isosceles, since those two sides are equal. And we learned from the front, if the two sides are equal, then the two base angles are equal. So the two base angles are going to be the one that's labeled 42, and then this one over here. Which means we should be able to find out this angle, our vertex angle, by using the fact that triangles sum to 180, all three angles. And if I remove the two angles that we already know, we're going to be left with 96. So if I put over here my angle of 96, now I'm going to go back to the triangle, the other triangle, and I'm going to notice I have to find angle C, and angle C is in this blue triangle. But if I extend this line out, notice where your exterior angle is this time. It does more than just use the x plus 12, it goes all the way over. So when we're seeing things like the exterior angle, don't forget you have to add the 96 on this case. So the exterior angle is equal to the sum of the two remote interiors. Okay, so we're going to combine like terms. So I'm going to have x plus 108 on this side, and on this side I have 5x plus 8. And I'm going to move the x over, so I have 108 is equal to 4x plus 8. I'm going to move the 8 over to the left side, so now I have 4x is equal to 100, which is going to leave us with x is 25. Now again, we're not done. We have to find angle C. So could do this a couple of ways. We could find the top two angles of this triangle, subtract it from 180 to find C. We could use the fact that the exterior angle plus C is equal to 180, and that's actually the way I'm going to go with this. So if I added in here 25 that we found for x plus 12, that's going to leave this angle to be 37. So right now I have 37 plus 96 plus the C that I'm looking for equals 180. They're adjacent angles on a line, and so they add up to equal 180. And if we solve for this, combining 96 and 37, I get 133. So solving for C, subtract over the 133, and we're going to find C is equal to 47. So that's just a little bit about angles, using a whole bunch of properties from our last units and this unit, putting it all together. Hope that helped. Don't forget to like and subscribe.